Good morning to all participants. Once again, welcome to day 2 of FTP. Today's session will be led by Dr. Archana Jain, who is currently serving as an associate professor in the Department of Computer Science and Engineering, Cyber Security at Vimal Jyoti Engineering College, Chemberi, Kannur. She brings with her an impressive 19 years of teaching experience, demonstrating strong academic expertise and dedication to student development. Her areas of interest include medical image processing, deep learning, and convolutional neural networks. Dr. Archana has made significant research contributions with 22 publications in reputed journals and conferences, including 2 Scopus Indexed and 2 IEEE papers. With her profound knowledge and research experience, Dr. Archana continues to inspire and guide budding engineers in advancing their understanding of emerging technologies in the field of computer science. We welcome you, ma'am, to lead this session. Over to you, ma'am.
Thank you, Pooja ma'am, for the wonderful introduction. So shall we start?
Yes, ma'am. We shall
Okay.
start.
Hope you are able to see the screen. Are you able to see the screen?
Yes, ma'am, we are able to see that.
Okay. Okay. Good morning. I will be talking about generative adversarial network with the fundamentals and applications today. So we have very less time. So we will only be discussing about, we will be just focusing on the introduction, then the architecture. I'll just show you the agenda. Introduction and discovery, like how, what made uh, this GAN possible and what is GAN, then training and deep learning basics. So there I will be giving you the introduction about what is training in deep learning and what are the different parameters, then about the introduction of GAN applications. And in the introduction of GAN, I will be using different diagrams about how it works, then the application. So that will be the general application part, then comparison with traditional approaches, then there's the data sets and evaluation metrics that will be used in GAN, then real world applications, limitations and challenges, ethical and safety considerations, and the applications in image processing. So the applications in image processing, I will be covering a bit more since my area is image processing. So I will be just focusing more on image processing. So what are the different applications that are available uh, in image processing that is related to, that is using GAN. And now it is like this one of the most exciting breakthroughs in modern learning process. That is what is considered as GAN. It is more powerful model that is capable of generating images, and it has a very uh, huge scope today. So when you see these images, see, please understand these. None of these people who are seen in this screen, they exist. These are just fake images that are generated using GAN, and now it is considered as one of the influential, innovative AI tool or approach that can be used in image generation. So this is another image which looks very much real. Now the beginning, talking about the beginning of what made that is, they were like at the initial stage, they were even thought, how is it possible for a computer to learn and create something which is very much real? or is it possible to generate a painting which will be considered as an original model, or is there any possibility of generating a message or a voice message which never exists? So this question led to the development of generative adversarial networks. So these questions, all these in various area or various situations, have led to the generation of GAN. Now about the discovery, in 2014, actually in 2014, this approach was first introduced by Ian Goodfellow, and it was like in an instant moment, they were in a situation where they just thought of creating something which will be competing with each other, something like two neural network models, which will be competing with each other, and then finally based on that they were supposed to identify a real one or a better model which can be considered for their research. That was the reason, and that is how that first situation that let them identify this approach. Now about the GAN. So this is it is something which it is very much familiar. So that is if you have some information to be created, and if you want to put it in the as an experimental piece and leave it for evaluation. So there are many factors which are to be considered, like how do they will it be better enough, or will it be able to sustain with the real image? So those things that were considered when this was identified. Now about so before, as I have given in the agenda, I told you I will just give you the introduction about GAN, then I will be discussing about training and deep learning basics. So let me start with that. What is training in machine learning? So now we already know that these what are these approaches which we will be using. They are all part of this machine learning, right? So what is training? Training means teaching a model to make correct decisions or generate correct outputs. So that is done by showing it examples, or it is something like there will be a pre-planned model, or there will be a approach that will be already designed, and it should have a real output. And so that when there is an input that is given, this output that is being generated in the training process, it will be used as a model for a comparison. Okay, and it is something like how we humans, how we learn. So when we are given with a new thing, we will just look for an example, right? We will just see how it works, and what are the ways by which we will be able to just experience it. And when we are experimenting or experiencing that particular model, there will be chances for mistakes. And based on the mistakes that are committed, we will find out corrections, or we will find out the solution. And when you are finding out a solution, that means the correction method for that particular example. Okay, so that is training. And training, this is what is the equation: learning from data to improve the performance. So this is what is called training. See, we will be using when we will move into the concept of GAN, we will be using these terms. We will be talking about training data set. We will be talking about this weight and all those things. So that is the reason I'm giving the introduction. Now, how training works. So the step-by-step description. Normal neural network, that is image classifier. And in there, the input data, that is when you are just taking an image, that is we'll just assume it is digit 7, and it is given to the model. See, already I told you what is training. See, there is a model and there is a very clear setup how it works, and finally how the output looks. Everything will be clearly framed. Now, when you are working with a training process, so first you will have your input data, and that is given to the model. Now the model will produce an output. So for the input given, there is a corresponding output that will be generated. The model's output is compared with the correct output. Okay. So that is what is the correct output that was estimated by the model? That was actually 7. Now you are checking with what output you have generated for this input data. Okay. Now there is an error, that is a difference between prediction and truth, and this value will be calculated. Now, when there is a difference, now there should be a chance for back propagation. So you have identified that the output which the model has given you for your input is incorrect. So you cannot just accept it. What you can do, you can go back, that is what is called back propagation. You will go back and then you will start with the same training process again. So this is how training works. And in deep learning is a subfield of machine learning, which itself is a part of artificial intelligence. Okay. So now coming to deep learning. So we are using deep learning approach. So this comes under the machine learning approach, and it uses artificial neural networks with many layers. We already know that. Okay. In deep learning, we will be using different layers. That is neural network layers, input layer. Then there are many hidden layers, output layer, and all those. So these terms we will be using in the concept when we are learning about GAN. Now, famous deep learning architectures. So these are the various deep learning architectures that are available. GAN, CNN, RNN. So you must have heard about all these terms. Now, GAN, it is used. I mean, I have also mentioned about the place where we will be using it, the field, or what is the purpose, or where are we using these various deep learning architectures. GAN, it is mostly used in data generation. That is what we have seen in the introduction. We can generate image, we can generate voice, you can fake image, you can make modification to the image. All those data changes can be made possible. CNN, convolutional neural network, that is also used in image processing. Then RNN, recurrent neural network, that is used in sequencing of data. Something like, see, when you are dealing with a continuous stream of data, and when you are checking for their continuity, and if you are feeling, if you have to have a huge bulk of data, you can make use of this RNN. So that is the purpose, or that is where RNN can be used. And next one, LSTM, that is long short-term memory. That is some situations you will have to, in some deep learning approaches, there will be situations where you will have to take a break. You will have to just stop, then perform some task, and then again you will have to continue. So, and also you will be dealing with a large bulk amount of data. So that is where this LSTM can be used. Transformers, that is used in language models. So there are various languages. There are few examples given here. Okay, that is that comes under language processing. Then autoencoders, that is used in compression. So most of these are related to image processing. So when you have a large, huge file and you want to store it, you want to transmit the information, and if you want to, in order to save the storage space, if you want to transmit it, you will have to just reduce its size. So in that part, we will be using this compression, and this is the deep learning architecture that can be suggested. Now, training in deep learning. See, already I have told you what is training in the general machine learning. So it is the same, but I can just explain again. Training in deep learning, that is, training is the process through which a deep learning model learns patterns from data. So something like you are giving an input data, and from the input data there will be patterns that will be generated, and it adjusts its internal parameters. So something like weights and biases. Like See, depending on the type of the data that is given, the data will have various parameters. For example, if you take an image, the different parameters that can be possible for an image are the pixel values, then how much is the resolution that is given by the pixel value, then what is the total space that image will be occupying for that particular process, and other parameters that is related to the performance. Okay, so similarly, so it will be, you will have to just identify what are the different parameters that will be related to that particular data and its predictions. See, also another term that is used in training, we will use the term prediction for output. So when you are generating a particular output, you will be using, that is what is the predicted value. So that means it should be understood as it is the output that it will improve over time. So every time you are entering through a training process, every training will be giving you with a particular prediction value. And if you are okay with that prediction value, or if you are okay with that output that is generated, you can just take it, or you can just go perform back propagation, as we have already seen, and you can just perform the task again. So this is the general representation. This is for our easier understanding. I have just returned this input, forward pass. So that is what is the first level in a training process. Then loss, that means you are getting output, but it is not matching with what is being predicted. In case of a loss, you will go for back propagation. That means you will come back, you will perform again the same task, and then wait update. So wait update means, so when you are performing back propagation, there are more possibilities for the parameters to be modified. Okay, so when you are sure that you have got the wrong output, you cannot believe that the input which you have given earlier was correct. So you will have to make some modification, and only then you can go for a better output. Okay. So similarly, you are updating the weight. So the weight means the internal input parameters. And now as a result of this, you can expect an improved prediction value, that is improved model. So this is the flow. This is how this training in deep learning process happens. So I'm just making it very simpler so that when we will enter into GAN, and also in GAN I'm not I'm not entering too much deeper. I will be only just covering the basics. Now next, this is the training. Now model in deep learning. So now what is a model? See, already in the previous slide I have told about a model. Now in deep learning, a deep learning model is a computational structure made up of multiple layers. Already I have told you. You have different layers, that is input, middle and output layers. Middle layer, that there will be hidden layers of interconnected neurons that learn patterns from data by adjusting the weights during training. So these weights are the parameters that are being passed. So based on these weights that are being passed, you will be going through the training process and there will be output generated. It takes input data, processes it through several hidden layers, and produces an output such as prediction. Okay, so this is it. So it's the same thing. I just wanted to make it clear how model, or what is a model in deep learning. Now, important terms in training process. First one, batch, that is a small group of samples processed together. So that's what, when you are dealing with a particular input or particular data, you will have a separate batch. So that is the term that will be used. Next one, epoch, that is one full cycle of training over the entire data set we will be using. When you are using a particular data set and when you are going through a training procedure, the entire cycle. So starting from, so this is one, input till the improved model. So that forms one full cycle. So whenever you are calculating the result, so when we are writing research article, we will be in the performance evaluation. When you are using a deep learning algorithm, you will have to mention how do you calculate, how do you evaluate it, and there you will be in need of showing this epoch value. You will have to show for this one epoch what is its result. Okay, then learning rate, a small number that you will control how big each weight update is. That is, for a particular weight or particular input parameter given, what is the result that is being finally obtained. Overfitting, model memorizes training data but performs poorly on new unseen model. It is something like not what is being expected. Underfitting, it is too simple and cannot learn the data patterns. So the model is working below what the estimation level. The other one, it is beyond. This is the lower level. Now, outcome of training, uh, recognize objects, classify text, predict future values, generate images. See, in GAN, this will be mostly the outcome that will be expected after every training. So after every training procedure, so for the different type of data sets or different type of inputs, there will be different types of outputs or predicted values estimated. In the case of GAN, it is images to be generated and translate languages. So these are the different outcomes that can be expected. Now coming to generative adversarial network. So it is already I have told you it is actually a deep learning approach. So that will be working using two models or two neural networks, generator and discriminator. So whenever we say about a GAN, that is a generative adversarial network, so we will have to have these two uh, that is neural networks, generator, discriminator. So now I will explain what are they. The generator learns to generate credible data. That is the data. See, when I am using a particular GAN approach in image processing, so if I want to generate an image, I will be making use of this generator for generating or for creating one image. The generated instances become negative training examples for the discriminator. Like now, whatever generator is has taken, the next level discriminator will have to check whatever the generator has done, is it correct or wrong. Okay, so that is the role of discriminator. Discriminator learns to distinguish the generator's fake data from real data. So that is, say, I can show you one figure. See here, just a analogy, that is um, thief and police model. So if the generator is a thief that is making fake notes, discriminator is police. So that will be checking if that note that is being generated by the generator is fake or real. Okay, I hope now it is clear. Whatever generator does or whatever output or whatever result the generator will be bringing out, the discriminator will be cross-checking it. Discriminator will never accept it and it will be checking if it is real or fake. Okay, so that is the role of generator and discriminator. And also it is to be noted that these two networks are mandatory. In a GAN, you cannot just perform GAN operation only using a generator or only using a discriminator. Now overview, see, I will be showing you different diagrams that will be explaining about this GAN architecture. That is overview of GAN structure. First one, when training begins, see, already we know what is training process. The generator produces obviously fake data and the discriminator quickly learns to tell that it is fake. So this is another example. This is the generated data, something not real, right? And it is fake. Now the discriminator will be identified. Discriminator will say that it is fake and it will be showing or it will be identifying. If there are two inputs given, one input that is given by the generator which is fake and the other input that is the real currency. Okay, so now it is the role of the discriminator to identify which is the real one. Okay, so this is the overview of GAN structure. Now this already I have told. Now another illustration of how a GAN works with an image. Now you can see we should be going from the it's not top-down approach. We'll be moving upwards. So this is the noise, and you have a noise, and now the generator is generating an image with the noise that is being given. And now the discriminator will have to identify if this noise, see this generator given image or generator generated image. That is the reason it is given as GZ. Okay, so this is the fake image. And this is compared, or at the same time, a real image also has been given to the discriminator. Now the discriminator will have to identify which is the fake and which is the real image. Now this real image will be, if the real image is taken by the discriminator, that means that function or that training will be complete. Now what happens? Sometimes the discriminator may be accepting this fake image. See, and also please note that it is not that the discriminator will be knowingly doing this. The discriminator will be confused. The discriminator will not be very sure which is the real and which is the fake. So now it will have to check. It will have to go through the different stages, and it will have to go through the training process and identify which is the original, and then that will be taken. And that will be considered as the predicted value. Now, working of GAN, see again, little more detailed description. Real image generator network, that is fake images. Now you can see that this is the real image, and this is a generator, that is fake image, and this is given to the discriminator network. And now the discriminator network will have to identify. See here I have shown this fake image as red and the real image as green. Now the decision on who will win. So what does that mean? Decision on will the generator win or the discriminator win. So if this discriminator is taking this fake image, that means the generator is fooling this discriminator. So in case if the discriminator is able to identify which is the real image, then the real image will be considered, and then now the discriminator will be winning. Okay. And now how GAN works, this is another representation. Generator creates fake data. Generator creates fake data, that is an image from random noise. Discriminator will evaluate the data. The discriminator compares the fake data with real data and tries to distinguish them. Okay, so now, and also understand that this discriminator, it will not be just blindly accepting anything given by the generator. The discriminator will be evaluating. It will have its own training process. It will be checking through the entire scenario, and finally the decision will be taken. Now, feedback loop, after the discriminator will evaluate and give the result. Based on the discriminator's feedback, the generator will adjust and improve the fake data. Now, even in case if the discriminator is identifying that the data that is given is fake, what does the discriminator do? Discriminator will inform the generator, you have given fake data. Now, what will the generator do? It will start trying another attempt. So now when it is trying with different images or different attempts, now the quality of the image that will be given by the generator also will be improved. Okay, so that is considered. That is the what is meant by this feedback loop. Now architecture of GAN, another detailed architecture. You can see there is one real image, and see, please understand whatever given in blue green color represents the real image representation, and red is the fake. Now random input, this is the random input, it is given to the generator, and the generator is, there is a model, I am using the model, generator is generating fake image, and this fake image is given to the discriminator. See, these are the different components. You have this random input, you have this generator who will be generating this fake image, and discriminator who will be identifying. The functionality of the discriminator is to identify or estimate which is the real one and which is the fake one. And now see, please note, you can see this representation. This shows the training process. You have this training process that is running in the generator as well as the discriminator. Now, after this the training that is happening at the discriminator, this out of these two images, this real image and this fake image, one will be considered. You can see if it is real, that means it is a win for discriminator. So that is why this is shown. And if the discriminator is choosing this fake image, that means it is a fake or it is a loss. And discriminates fake real. So this is the update. So this updation, it is actually happening at the discriminator's end. Now, the continuation of the previous diagram, random input, generator, sample, real images are there. That is also given as a sample. And now the discriminator loss or generator loss. So it is, if the discriminator is losing, that means the generator is winning. If it is the reverse, that is either one of them will be winning the training process. Now, so I have shown the architecture and I have just shown the step description, how it is done. Now let me explain the stepwise procedure in GAN. So how is it happening? What are the different steps? First one, define a GAN application based on the architecture. So something like this. Based on this architecture, there will be an setup that will be defined. So like where it starts, what is the random input that is to be given, then what will be happening at the discriminator and all those things. Then the second step, I can explain each step. Definition of a GAN application, that is a GAN application based on its architecture, refers to how different GAN structures, that is, are designed to solve specific tasks. So that is what I have told you, how this generator and discriminator arrangements are done. Okay, and that is being done based on the input and the output that is to be generated. A GAN application is a problem that can be solved by designing the generator to produce a specific type of output, such as images, audio, or text, and the discriminator to evaluate its realism. So now, realism in the sense how exactly the what image appears to be. So for the purpose, see if an image is being used for any medical disease diagnosis or something like that, then there are many features which are to be considered. So based on those properties, this discriminator will have to identify that particular image. Okay, so that is it. Now the architecture determines how features are extracted. And something like where it starts and when the random input is given. So is that input well enough or well framed so that when it comes to the generator, the generator will be able to generate the corresponding image there. Okay, so all these things are done at the first step. Second step, that is here I have written general steps. Second step, train the discriminator to distinguish real and fake image. Okay, so this is the second step. And also the generator will be usually represented as G and the discriminator will be represented as D. Discriminator is a binary classifier whose job is to tell whether an input image is real. See here from the data set, we are labeling the real image as 1 and fake, that is generated by the generator, as 0. Okay, so that is how see when you are giving a choice, when you are asking someone to find either one of the two choices, they should be given, right? One is for this, two is for the other one. So something like that. So something like that, here you have this real that is represented using label 1, fake, that means it should be coming from the generator and that will be labeled as 0. Training the discriminator involves improving its ability to correctly classify these two types of images. So that is what I told you in the architecture, what we have seen in the broad, that is detailed architecture. In each level, in the generator as well as in the discriminator, you can see that there is a training figure that is being shown. So now what is the responsibility or what is the training that is allowed for a discriminator? So that is improving its ability to correctly classify. So the training will be done accordingly. So what are the ways by which the discriminator will classify or identify the real image? Okay. Now it computes the loss or both real and fake inputs and updates its weight so that it becomes better at distinguishing real images from fake ones. So now that is the role or that is the training that will be given to the discriminator. Now the third one, training the generator. Generator is trained by producing fake images and passing them to the discriminator, but with the target label set as real. Okay, that's it. See, whenever the generator is giving a target or a data to the discriminator, it will not be giving it as a fake one. It will be setting the label as 1. because one is the label that is usually given for real image. The generator updates its weight so that its fake images become realistic enough to fool the discriminator into classifying them as real. So that is it. So this is how the training will be given for the generator. Now, training for multiple epochs, that is, the generator and discriminator are trained repeatedly for many epochs, where each epoch updates its weight through real and fake samples. See, already I have given you the definition of epoch. What is it? So, it is one full cycle of training process. So, that means starting from the input till the improved model or till the place where you are getting a result or a prediction. So this training will be done for every single epoch. Okay. Over time, this iterative training improves the generator's ability to produce realistic data. So that is it. See, when you are asking someone to fake, and if there are many chances given for that faking to happen, there is a possibility for that person to generate a very clear output. Okay. So that is what is being told here, to produce realistic data and the discriminator's ability to detect fakes. Now, every time this discriminator is also able to identify that this generator has given a fake data. Now, on point, then now the discriminator also becomes very clear. The discriminator also will be reaching a point where it can identify if it is a fake or real image through various training experiences. Now the next step, saving the generator, that is after training, the generator model is saved so that it can be used later to produce new realistic fake data. Now this is a situation where at the end the discriminator is identifying a real data and giving it as the improved model. Okay, now the process is over. Now what happens to the generator? The generator will be whatever process it has done, it will be saving it and it will be using, it will be understanding that, okay, I have got so much of training. Now I will make use of these experiences, what I have learned through this fake image creation, and I will use it for the next time. The same generator can generate high quality synthetic samples directly from random noise. Now, because of all these times training has been done, now the generator will be able to generate a high quality image. Generator may be. Now, so that is about the steps. So these are the steps, the procedure that is happening in GAN. What are the different steps? So that is what I have explained. Now, both the generator and the discriminator are neural networks. Already I have told you. The generator output is connected directly to the discriminator input. Okay, so whatever is coming out, so that is how the architecture is framed. Whatever is coming out as output from the generator, that goes as the input to the discriminator. Through backpropagation, the discriminator's classification provides a signal that the generator uses to update its weights. So these are the steps. Now about the GAN training, because a GAN contains two separately trained networks, its training algorithm must address two complications. That is, these are the two complications that may happen. GAN must juggle two different kinds of training. That is, generator training and discriminator training, because the generator will be trained in a particular order, so that needs to be considered. And what is the training that is given for the discriminator, that also needs to be considered. GAN convergence is hard to identify. So that is, if there are any confusion or if there are any detailed issues in any one of these training procedure, that will be very hard to identify, because that will not be understood. They will only continue with this process. Whatever input is given, discriminator is identifying if it is fake or real, and this just goes on. So these are two complications that are possible in the case of GAN training. Now, variants of GAN, vanilla GAN, that is the basic GAN. Vanilla GAN, that is the basic GAN, then deep convolutional GAN, conditional GAN, and cycle GAN. So these are the different, there are many varieties of GAN. These are the few which I will be discussing. First one, I will be just explaining about conditional GAN. Conditional GAN actually, see, when you are giving two choices, and if you are very sure that it belongs to one particular category, and you are giving the generator, that becomes the conditional GAN. Conditional GANs are similar to standard GANs, except they allow the model to conditionally generate samples based on additional information. So that is, for an example, if you want to generate a cat face given a dog face picture, we could use conditional GAN. Okay, I hope it is clear. So you are giving a cat face and you are asking finally you are supposed to get what you are expecting. So what are you expecting out of that particular training process? So that you will give, we will be providing. So that is what is called conditional. So vanilla GAN, it is the simplest type of GAN and it is merit foundational. Merit foundational means, so if you are using a particular GAN for a particular purpose, for example, in image sharpening, that is one property of image enhancement. So when you want to focus more on a particular area, or if you want to have a particular performance metrics to be identified so much compared to the other evaluation metrics, you can just trust or you can just prefer this type of GAN method. Okay, and it consists of a generator, discriminator. Both are built using multi-layer perceptrons. That is, the model optimizes its mathematical formulation using stochastic gradient descent. That is, so these are the mathematical steps or formulation that will be followed in the training process. And now issues with this vanilla GAN, it is mode collapse. That is, it may be producing a particular type of output repeatedly. So you when you are expecting a different, and if you are, even if there are some changes that are being given to the input parameters, then you may not be identifying better difference in the result. Now, unstable training, that is another method, another issue with the vanilla GAN, that is, it is may not be. So, you for a long or a large application, it may not be suitable. Then deep convolutional GAN, that is uses convolutional and transpose convolutional layers. High quality images are generated, perform stable training throughout the process, like stable training. So this is what is missing in the case of vanilla GAN. There will be, see, when generator is given a training and it will be providing the result in the, what is expected. Then strided convolutional instead of pooling, that is, so that is one method. Strided convolution is a method that is used here in deep learning. And that pooling method has a property of just interfering. It will not be giving more attention for a particular property. If you have edge preservation or if you want to perform edge detection, you cannot use this process of pooling. So better to have this strided convolution method where you have the choice of what is to be given more priority. So that is allowed here. Then batch normalization. Then the next one, ReLU, that is used in the generator, and leaky ReLU, that is used at the discriminator. Okay. So these are the different, that is GAN variants that are available. Now, applications of GAN. Already at the first introduction slide, I told you, generating fake data for augmenting other machine learning algorithms. So that is first application of GAN. Image to image translation, text to image. So these applications we will be discussing when we are covering this image processing applications of GAN. Super resolution, domain transfer, that is local minima to equilibrium model. That is something like you will have to switch from one particular level. That is, you are focusing on a particular area, or you are focusing on a particular approach. If you want to move on to another approach for that particular end result, it is possible using this GAN. Okay, and generate faces. See, I can show you this website. This person does not exist. I have just opened it. I can just show you. This is the website. If you can just see that, this website, if you open, you can see that you can see many images. These are GAN generated images. These are fake images. So this website, you will be able to get more images that are generated using GAN. So this person is not real. That is the name of the link. This person does not exist.com. So when you go there, you will see that you can see different faces that are generated that are not real. Okay, and that is about the applications of GAN. Now, generative adversarial networks, general application category, image in terms of images, image synthesis, image editing, image to image translation, video. So, in video also you are allowed to perform different modifications, speech that is audio, then science. There are instances where there is data that is being available in bulk, and you are not able to identify which is real and which is to be taken as the input. So if we are applying this GAN method, I think it will be for making the prediction. Now application again, this is another flow, image generation, widely used in creating realistic images, faces, art, etc. Then data augmentation, more data for training. That is, sometimes you are given with a small data set. From that data set, if you want to create some, you cannot call them as dummy, but it can be acting as a dummy data set. Then super resolution, GANs improve the resolution of images. See, if I want to improve the clarity, see, when you have so many methods that are available for improving the clarity of an image, that is image enhancement approaches, using this GAN, even it is possible. Okay? Text to image, textual description into corresponding images. So this is the applications. Typical GAN architecture. See, we will be using these in our image processing applications of GAN. Okay? And I will be using these terms. If I have enough time, I will come back and I will be explaining this. Now, data sets commonly used for training and for evaluation. This is FCHQ, that is the short form of this. Flickr Faces HQ, high quality face data set that is used with StyleGAN. StyleGAN is one of the very prominent, that is example where you will be using. We will be using it in image generation, etc. Okay, so this is one data set that is very commonly used. Celeb A HQ, that is used for celebrity faces with attributes. This is already available, and these are the different data sets available. ImageNet for class conditional generation and large scale image task. Coco IDES 20K for scene generation. So this is something like for video generation. Evaluation metrics. See, when you are using GAN, the various few of the evaluation metrics that can be used are FID, that is freshet insertion distance. This is also yet another important evaluation metric. It measures the similarity between generated and real image distribution. It is lower is better. Something like whenever we are using this GAN, already I have shown in the architecture, you have a real image, and along with the real image, you have this generated fake image. Okay, so now at that time, when you will have to identify, or when there is a chance for finding out the similarity, so this factor can be used. Then IS, that is inception score, it measures quality and diversity. That means how do they differ? So how much good? See, whenever you take an image, we know, right, there are very metrics, evaluation metrics, PSNR, and different values. So now whenever you have these values, we already know. So this parameter, so if it reaches this level, you are able to identify that this image has better quality. So similarly, this inception score also, it has a particular limit, and based on that, it can be identified. And the problem is it can be manipulated, so it should be used carefully. This inception score can be manipulated, so that needs to be, during the training process, it needs to be very well handled. Then PSNR, SSIM, we already know peak signal to noise ratio, that is SSIM, structured similarity index measure. So these are the different variants that are used at the time of reconstruction. First one, PSNR, that is pixel level metrics. So when you are dealing with the resolution, if you want to improve the resolution of an image, So you will have the PSNR value of the original image. Then after you will perform various algorithms or various approaches to improve the clarity of the image. You will again perform this, you will again calculate after getting the enhanced image, you will be again calculating this PSNR value. So, and you should make sure that you should be getting a higher value of PSNR compared to the original. Okay. So similarly, SSIM, that is structure similarity index, that is used in mostly for edge detection, that is at the boundaries. So structure similarity index means, so whenever you are having an image and you want to concentrate more on some region in that image, such as boundaries or some prominent area, so you will have to calculate, and this parameter or this metric can be used. Okay. And this is not about much about the quality, it is about what score you get. Based on that you will be able to identify, and these are all quantitative measures. I hope you know, or there are quantitative and qualitative measures. Quantitative measures or quantitative evaluation metrics are the ones that are giving you an estimated value, and based on that value the result, that is the output, or at the conclusion part you will be able to say that this image has reached these parameters and hence it has better quality. Then LPIPS, that is learned perceptual image patch similarity, that is it measures the perceptual closeness using deep features. This is something very much related to deep learning approach. In deep learning we will be using this metric, and that is used for, and this is no way related to this image uh, enhancement or anything. This is something that is how close is that based on a particular training parameter that is given. So it is identified accordingly. Human evaluation user studies, that is often necessary for perceptual quality, realism and preference. This is something like a qualitative analysis. So what do you see and how is it, how it looks. So this is these are the different evaluation metrics. Now, typical application pipelines. So these are the different pipelines, and these are how we will be using these various evaluation parameters. First one, collect and pre-process the data set. So this is in the case of this crop, align faces, uh, for particular functionality. For various functionalities, how do you perform this? Select model and loss mix, that is for adversarial, perceptual, train discriminator and generator alternatively, that is for some stabilization techniques. Monitor metrics, so that is what these quantitative measures. So you will have to visualize the samples frequently. So for a particular image, what is the value you got? Next time after you will perform the training, then again you will have to visualize. Post process output, that is color correction. If you want to make a change in the color, so that is it. Now use cases and real world examples. Photo editing tools. So you can have these automatic object removal, background replacement. So these are the different tools that can be used. Entertainment and media, that is generate characters, textures or concept. Medical imaging, super resolution. So this we will see now. E-commerce, generate product images in different colors. See, in e-commerce, you just want to make it a fake. So maybe in a website, if you are selling things, and you just want to have in online you have to just have a model, or you will have to just show that you have it in different colors. We may see that, right? It will be like so that purpose this can be used. Heritage restoration in paint damaged artwork, something like if some artwork got damaged and you want to replace it, you can make use of these techniques. I am talking about the photo, or when you are just keeping an image and you will have to just frame it. So this can be applied. Now limitations, collapse and unstable training. GANs can generate limited diversity if not carefully trained. It can have different issues. So this training, the training that is given at the generator end, if it's not properly aligned, it may give a different data, right? Then hallucinations, incorrect details, especially in critical domains, that is in medical imaging, outputs may look plausible but be inaccurate. Something like, see, medical imaging, mostly if you are using in diagnosis, the images which is generated needs to be very clear. So if there are issues in that, if there are incorrect details that are given, that can lead to issues. Evaluation difficulty, that is, numeric metrics don't always match human perception. Sometimes that can happen. Then data requirements, high quality data, large data set yield best results. Then computation cost, high resolution GANs require substantial GPU resources. So these are the different limitations. Now, ethical and safety considerations. Now, I will come back to this after discussing about this medical applications. So these are the general applications of GAN, image generation and enhancement. See here, these are the tasks. These are the various tasks that comes under image processing or image generation, image synthesis, super resolution, image to image translation in painting. Okay, and these are the different architectures that will be supporting these tasks, and these are the different losses that are possible, and these are the parameters or performance metrics that will be. We have already seen this. These are the metrics that can be used for the calculation of these losses. Okay, this is only image processing. Now, video and animation, art and design, AI generated art tools. So these are the different, see, these are different images or different tools that can be used for generating paintings. Style transfer. See, you have it, if you just assume that you have an image in Van Gogh and you want to convert it into some other model, it is possible using this GAN. Then data augmentation and simulation. Medical imaging, generate synthetic MRI, CT or X-ray images to train diagnostic models. That is, if some fake, if I want to have it for a presentation, for example, I wanted to show that these are the different approaches and these are the different possibilities and this is how it looks. So I can make use of this GAN model, and as a part of that I can use it for augmentation. So I will be able to have a demo that looks exactly like an MRI or a CT or X-ray image. Okay, so that is possible. And now this happens, and finally it will not be. I will have to show them, or I will have to tell them that these are GAN generated image, and then you will not be in trouble. Okay. Then autonomous driving, simulate street scenes or rare driving scenarios for safer model training. So that is something part of simulation, something like a model. Human and facial applications, face generation, that is human faces. So this is the website. This is what I have shown you. This person does not exist. This is a very clear example for face generation using GAN. And virtual avatars, like realistic avatars for gaming. We see that there are different, in the various gaming applications, you see that there are different avatars or different visual representations that appears, we already know they are fake, and those can be generated using this GAN. Facial expression synthesis, that is modify or generate specific expression. So you can have a very clear change that can be made to a image, that is to a particular part of the image. Text, speech and audio, it is voice conversion, change one person's voice to sound like another. So that is another possibility that is using GAN. Music generation, compose new music pieces based on patterns learned from dataset. Speech synthesis, so natural sounding voices, that is AI narratives. You have that is also done using GAN. Text to image conversion, that is generation. So this is another application. Scientific and industrial applications, that is what I told you in drug discovery. Say you have some set of molecular structures and you will have to find out using a particular property, out of that which one is illegal. Okay, that can be done. Material science, predict new material compositions. So that is through various training approaches. Astronomy, enhance telescope images and simulate galaxy formation. So you will be given with a data set and take it as a model, and that can be given to GAN, and finally real image can be generated. Cyber security and privacy, adversarial training, improve robustness of model by generating adversarial examples. That is, uh, some situations where you will not be able to give a real model. Okay, so there you can give a particular example, or you can create a robust model using this GAN, and that can be given as a sample. Okay, that is made possible. Data privacy creates synthetic data sets that preserve statistical properties but hide sensitive information. Something like statistical data. So we may just, you will have a very less amount of statistical data. Statistical data means, see, for a particular incident, these are the different information. This is the information available. This is the time, and this is the duration. So it happened for 5 days. So something like some information available. And if you want to make it a little more exaggerated, and if you want to just try it for a huge bulk data set, you can make use of GAN. Gaming and virtual reality, already I told you, that is for scene generation. Realistic 3D environments for game or VR. Okay, virtual reality, there you can see that there are different models that are being shown. So those models can be generated using that. Character design, automatically generate new characters or NPCs. Now, research prototype generator. See, when you are writing a proposal, research proposal, and you wanted to have a prototype of that, how it works, or what are the plan, how are you planning to go forward with that proposal, you will be able to generate design concepts quickly. Okay, and it can be used for the future. Idea exploration, help artists and designers explore variations of creative idea. They will have different options. Now, applications. So this we have already seen. How do this GAN differ from traditional machine learning? So this is the GAN, that is synthetic data. Here it is predict outcomes. Generator and discriminator both are there in this GAN, whereas in machine learning it is supervised learning. Also, see here, GAN we use unsupervised learning. Okay, adversarial training is performed, minimize error, realistic output, their regression and classification. So this is how it differs. And when you say that, since there is generator and discriminator, that can be considered as a bit complicated thing. Otherwise, it will be better. Now, practical approach. See, before that, I'll come back to this later. Now, the applications of GAN in image processing. So, only on image processing. So, these are the different image processing applications of GAN. First one, image generation, image to image translation, image super resolution, image in painting, style transfer, noise removal or noise denoising, anomaly detection. So these are the different few image processing applications that I will be discussing. First one, image generation. We all know generation means creating a new image. That is, create realistic images from random noise by learning the distribution of real images. And we are using here, style GAN is used here. See, we have seen these terms earlier. Different GAN architectures that are available today. One among them, and very trending one, is style GAN, and that is used in image generation. So this is the step. Input random noise, that is latent vector. That is, latent vector means you will have the pixel representation. That is, how do you represent an image? So that image value will be taken as the input. The generator does not take an image as input. Instead, it takes a vector of random values. That's what I told you. 100-dimensional noise, something like a noise. This noise represents a point in latent space that encodes abstract features like face structure and lighting. Second step, the generator network, a deep neural network trained to convert noise into an image. It gradually upsamples the noise into a high resolution image. See what is given by the generator. Now that is what is happening. See, it performs this, it will be converting this noise into an image and it will be upsampling. And I hope you know what is upsampling. You are improving its image quality. You are making this, you have your input image with noise and you are reducing it reducing the noise, and you are converting it into a high resolution image. Okay, and you are adding these layers, edges are added to the image, textures and different color patterns to that particular input image. Okay, and this is similar to painting a face from scratch. That is what is done at the generator network. Now at the discriminator network, a second neural network that receives real images from data set. So that means in the discriminator, we already know there will be a real image, also there will be a fake image that is being given by this generator. Okay, and these two are being taken here. It must classify each image as real or fake. So the discriminator will have to identify. So already we know that. Already we know Already we are familiar with what is happening in a generator and in discriminator. Okay. And now the generator improves by learning to fool the discriminator, while the discriminator improves by learning to detect fakes. Now, what is the training process that is happening? The generator creates a fake face from random noise. The discriminator compares it with the real faces. So these things are already done. Loss is calculated based on how well the discriminator can detect fakes. So how well this discriminator is able to identify whether it's a real or a fake image, that is the calculation of loss. Gradients update both networks. So these are the input parameters. Already I told you, when you are performing training, you will have some input parameters that are the gradients, weights, etc. After thousands of iterations, fake images appear extremely realistic. Okay. Now about style GAN. So that is what is used for this. One of the most famous GAN model for face generation and features style-based architecture. Okay. Controls, pose and mid-level features. That is, what are the different properties that are needed for a particular image generation? Those can be considered using this particular architecture. And interpolation, smooth transition between phases. That means if there are some small changes that are to be made in the transition phase, that process is called interpolation. In latent space, that means you can just vary. If you are making a few changes in the pixel values, image representation, this interpolation can be made possible. And high resolution output. So this is the output that will be generated. So this is how this image generation using style GAN looks. You have this latent noise. Out of this latent noise, using this generator, you are generating a face. Okay, this is the face that is generated by the generator. This face, it is just found, and it goes through the discriminator, and discriminator will decide if it's a real or fake image. Now applications, face synthesis. So these are the applications of this one, right? Okay, image generation. Virtual avatars, entertainment industry, that is in movie, so visual effects that will be mostly given using GAN. Artistic portraits creation, dataset augmentation. So these are the applications. Now the second application in image processing, that is image to image translation. Image to image translation refers to converting an image from one domain to another while keeping the core structure the same. Okay, so I'll just show you. See here in this image to image translation, different from the earlier approach, that is image creation, generation, we used only style GAN. Okay, but in this image to image translation, we will be using two different models. We will be performing it in pix to pix as well as cycle GAN. So what is this image to image translation? The edges, shapes, layout and geometry of the original image are maintained. Okay, so you are only just making few changes to the image. Only the style, color or appearance is transformed. Maybe you are just changing the color, how it appears, the overall formatting only will be modified. Now, pix to pix. First, we will be discussing in pix to pix. That is, there you have paired image translation, sketch and corresponding real photo. So this is where we will be. These are the different examples we will be using. And now, what happens at the generator? converts the input image sketch, because sketch is taken as the input, okay, into target image, that is the realistic portrait. Discriminator part, it is patch GAN, that is checks if pairs, that is the input and the output, look realistic. Okay, so this is what is happening in PIX to PIX. In cycle GAN, it is not it is unpaired image translation. See, if there is a multiple choice, or if there is a situation where you are asked to choose among these two approaches, which one uses paired image translation, it is PIX to X. Cycle GAN uses unpaired image translation. Cycle GAN, there will be two mappings, domain A to domain B. Then domain B, that is, uh, you will have just a transition from one level to the other, one translation. So I will show you the figure. See, image translation. So this is the first case. In the case of cycle GAN, this is the image if it is appearing at the daytime, and this is it appearing at the night. So that is an example. See, the first one, that is from the sketch, you are coming to a realistic photo. Now, the third application in image processing, that is image super resolution. So we can, it's well understood that you are improving the clarity, you are improving the resolution of the image. GANs enhance image resolution by generating fine details from low resolution inputs. So you have an image which has a very less resolution. Using GAN, you are improving the quality. SR GAN, it is used here, that is producing HR images, high resolution images for medical imaging or satellite data. See, usually medical imaging and satellite data, that needs to be of more clear. Okay, so those images are to be so much improved in clarity. So using this GAN approach can be providing the next level user with the predefined data. Image resolution, image super resolution is a powerful GAN application that is used to convert low resolution. That is what I have told. Low resolution images into high resolution images by adding realistic high frequency details. Okay. Traditional upsampling techniques, that is bicubic. So what happens? See, I will show you the figure. This is the figure. Here, this is the middle one, that is what happens in bicubic approach. And in every approach, how it looks. This is the initial one, low resolution, bicubic, and this is the SRCAN, what we have used. Okay. And application level, medical imaging, how it looks, and in satellite imaging, how it looks, it is shown. Now, coming to the how it works, GAN learn to enhance. That is, it will be enhancing the edges, textures, fine details, and color gradients. Okay, and what happens at the generator takes the low resolution image. It will be upsampling it through these layers. Upsampling means improving the quality. You will be increasing it can be in many ways. It can be by increasing the pixel values, then increasing the residual blocks, okay, convolution layers, and all those can provide upsampling to the particular low resolution image. Produces a high resolution image with fine textures. The generator focuses on restoring realistic visual details. So that is what the output for the generator. Now at the discriminator receives real high resolution images and generator images. So okay, it has already real image and this generator image. Now it will be classifying which one is real or fake. Forces the generator to create HR images that are indistinguishable from the real ones. Now, training losses. So, how do they calculate this loss? Already we know what is a loss. So, you have a training process, you get an output, you are checking with the estimated value. If it is not the one that we are expecting, that means there is a loss. Now, you will go back with the back propagation. SR GAN uses a combination of losses, content loss. So these are the different losses: content loss, adversarial loss, and MSE, mean square error. That is it. Pixel loss optional. See this one, it is something related to the resolution of the image. That is for preserving the structural accuracy. So that is why it is called as pixel loss. Adversarial loss, that is HR image looks real. It is something like how much is it able to fake, or how much is it able to make an impression that it is real. Content loss, how much the geometry group, that is features are being incorporated. Now example of image super resolution. So this is already I have shown this. Applications of SR GAN, medical imaging. So these are the applications. This is mostly used in medical imaging. Okay, enhances MRI, CT, ultrasound images, reveals subtle abnormalities for diagnosis. See, you will be able to identify there are a slight modification in the image. It will be identified. So that is the advantage. Satellite and remote sensing improves resolution of satellite photos. So that is why I told you this can be applied in satellite imaging also. Useful for agriculture, surveillance, environmental studies, security and surveillance. So these are the applications. Image in painting. That is, see, you have an image and it is identified that there are some portions where it is not complete. So if you want to modify, if you want to fill those gaps, or if you want to just polish those area, that process is called image in painting. GANs fill missing or corrupted regions in an image by predicting their realistic textures. So how it looks really or originally. So that comparison will be done, and based on that, this low resolution image can be modified. Okay. Example: removing unwanted objects from photos. So sometimes there will be photos where you will be something like something which you cannot perform using cropping or any image editing tool. If you are not able to perform, you can make use of this GAN approach and polish, or you can just redo that. Restoring damaged historical images. So that is another important application using GAN. So how is it possible? Object removal, historical image restoration, process of filling. So that is what I have told. What is image in painting? Learn to reconstruct image, that is missing pixels, scratched or torn areas. See, sometimes there will be photos, and in there some main prominent part may not, some like a slight modification, some part will be missing. So that can be identified, and that can be modified using this approach. Masked regions, some regions will be masked, and if you have to undo that, you can do that. How GAN-based imprinting works? Masking, that is missing region. See, this masking, it is something similar to like you have, you know what is there, but due to some reason that part is missing. So there will be situations, right? You will be in a situation to you are supposed to have a very clear image that is to be showcased, or that is to be presented, and unfortunately some part of the image is missing. You can just go with this. User removes an object or mask a damaged region. The masked area is set to blank pixels removed. So that is how it will be done. Okay, that area you will be setting as blank pixel. Then in generator network predicts the missing content, fill the region using learned textures. How do you mean by learned textures? Because through the early already available training data set. See, already there will be a model of this. There will be a model of this data set, and using this, they will be able to, the generator will be able to predict how what is to be used and in this situation. And discriminator evaluates the realism of the field region, ensures the painted patch matches the surrounding image. Image in painting. So this is the example. This is the damaged and this is the restored image. And there is a bit more differences. And types of GAN in painting: context encoder GAN, partial convolution GAN, edge connect. See if, what are the different approaches that are used in these techniques that is being told. Surrounding context is being used. Supposed to be, and you can just go through the training data set and identify how it is mentioned there, and that can be used in this model. Applications of in painting: removing unwanted objects, that is removing people or objects from photos. Okay, so that is a very obvious application. Cleaning professional portraits, removing watermarks or text. Historical image restoration. So these are medical imaging, filling missing scan region. Sometimes in the diagnosis procedure, they may be focusing on a particular area and that is clear, but some portion, the scan report, it is not clear. So what do they do? Instead of going for a redo, instead of performing the scanning functionality again, they can go for this filling that area that is not prominent. Okay, because the prominent region will be focused for the diagnosis procedure. Correcting corrupted imaging data. Now the fifth one, style transfer. GANs change the style of an image while keeping its content the same. Okay, so that is converting photo. Van Gogh, that is a model. It is something like a type of painting. If you want to convert that type of painting into Monet style artwork, so that conversion is what is called style transfer. That is an example. Style transfer using GANs involves transforming an image so that it retains its content but adopts the artistic style of another image. So that style, only that particular style will be modified. Preserve the original structure, that is the content of the image will be preserved. Overlay the style patterns. So these are the different style patterns that will be considered. Natural, artistic and high quality, that will be taken care. Now working content, what are the different images that is shown? Generated network applies the style pattern. So these are the different pattern, brushed, stroke and all those. And the discriminator, it will be comparing this with the real image. Example. So these are the different representation. For input photo, Van Gogh, this is how it looks. It is converted to Monet. See here, there is a huge difference in the style of the image. Now noise removal, that is a very important approach in image processing, that is denoising. Noise removal means you have a very important image. Okay, it can be a medical MRI or any image. And when you are giving it for diagnosis, due to the noise that is available in the image, the diagnosis procedure, the physician will not be able to identify the different patterns clearly. And due to some reason, sometimes they may not be able to take the scan or do the imaging process again. So here, low signal to noise ratio, that is SNR, especially that is in such situation, and the scan, you will have a very low quality MRI machine, that can be another reason. Patients move during scanning, so people will not be stable when the scan is being taken. So due to these reasons, the scan image that is generated will be of low quality. Now that will have more noise. Noise means any type of distortion that has happened to an image can be considered as a noise. GAN-based denoising models help improve image clarity without losing anatomical details. That's it. The prominent details will not be lost. Noisy MRI input, that is the actual MRI. GAN generator learns to predict the clean MRI from the noisy version, uses residual blocks, keep connection. So these are the different patterns that will be used based on the training data that will be available. And the GAN discriminator, real clean MRI and generated denoised MRI, and then it will be forcing the generator to produce MRI images that look realistic. Okay, so these are the conditions for the generator. Denoised MRI output, high clarity, high SNR MRI. We already know if you have a high signal to noise ratio, that means it has a good resolution. Better for radiologist interpretation. That's what I told you. The physician will be able to diagnose it in a better way, easier for them. More suitable for downstream task, tumor detection, tissue segmentation, radio mix feature extraction. These are the advantages. So now step 1, noisy MRI input that has low SNR. Step 2, pre-processing, that is normalization procedure will be done. Step 3, GAN generator. Then step 4, discriminator will identify which is real and which is fake. Then denoised MRI, that is the enhanced clarity wise image will be given as the step 5, that is the result. Anomaly detection, this is the last image processing approach. Unusual patterns by learning typical patterns and identifying deviations. Something like uh, some part of the image which may be added to the output due to some manufacturing issues, due to some abnormal medical scans. So those needs to be identified. Reconstruction based generator auto encoder style, that is train a generator on normal images only, then identify them. See, approaches are like they will have a very realistic training data set. Now this particular situation, see, we were discussing about anomaly detection, that is if there are any specific abnormalities that are identified which are known to the entire team. So using this method, we will be able to trace out that and remove it. Okay, if the model has only seen normal images, it will fail to reproduce or score an abnormal image like a normal one. Because the model should have a clear training that is given for identifying these abnormalities. So only if that is given, this abnormal situation can be taken care. Okay, so that is considered as one of the key factor. And key reconstruction based generator, that is we are using this auto encoder style. Already I told you this is used mostly in compression and in image, that is in noise removal. You These are the different strategy that is being used by the generator and the discriminator. And applications, CT scan of lungs. See, in most cases, the lung images that are obtained will be losing in clarity because the diagnosis of some of the diseases like pulmonary diseases, those diseases will be identified based on the patterns that are available in the lung image. So if those patterns are not clear, the diagnosis procedure will not be complete. So in that case, some patterns, if they are given some identification using these approaches, then it works, will be sufficient. Pixel level localization, that is most on the anomaly, that is the proper that corresponding area, how much is the pixel clarity that is to be added. Works with small data set. So this approach, it works only for small data set. And scalable. Now these are, and now let me go back and I will show you those architectures. These are the various architectures, GAN architectures that are prominently used. Style GAN, and it has different versions. That is a very prominent GAN architecture that is available today. Big GAN, that is used for large class conditional synthesis, that is in a huge large network. Then PIX2 PIX, that is used in image translation and image generation. Cycle GAN, that is unpaired image to image translation. So these are the different GAN architectures that are used widely today. Now about the ethical and safety considerations, deep fakes and misuse, high realism face generation can be abused. So that we all know there will be chances for images to be manipulated. And copyright and attribution, that is GANs trained on proprietary art raise, legal ethical questions about reuse. So that is also because it becomes, if somebody shares that fake generated image and everyone starts using it, and it can create a problem. Bias amplification, if training data is biased, outputs will reflect and amplify biases. That is, finally the clarity or the truthfulness will be an issue when we are just always going for biasing data. Mitigations, watermarking generated images, building detection tools, restricting harmful uses, and curating dataset response. It is something like it is what are the different changes that can be possible? So that is what is being told. You will have, so if there is any situation where for a particular application, if you need a particular image, so just if you are using it wisely, I hope these GAN images or GAN technique can be used for the society. Then practical tips, start with pre-trained models. That is it. With small data set, pre-trained models. So what happens at this situation? Find out the prediction and then based on that, go with the generator and discriminator model. Use perceptual losses for visually pleasing SR or style tracks. That is, perceptual losses means how what is the quality that is expected, identify that and based on that go for the method. Combine pixel losses L1 with adversarial or perceptual losses. Pixel losses means the resolution. If you have an image that is represented using a particular pixel representation, that needs to be combined with the other losses. Run small experiments at low resolution, then scale up to higher levels. Keep a safe set of validation images and track them during training to visually spot regression. So always have a real image training data set. Now into that, do the changes and then experiment on that. Now last, so this is the references. These are the references which are available based on image and image enhancement, all those. So there is GAN-based data augmentation. So there are various good work that is happening based on GAN in image processing. And there are many, I have included even the survey on application analysis of generative adversarial network, latest research articles. So if you can refer these, if you can just go through these, you will have, if there is a plan for doing a research on this, just find out what are the different survey available and just start with the general description of how, what are the different conditions, how deep learning works, and refer various articles that are related to deep learning and then come to GAN. And I hope it will be helping. So now concluding, GANs are powerful models that are capable of generating realistic artificial data. They have wide application, mostly in imaging, healthcare, entertainment, and research. And I would like to say that these are the more the recently available GAN architectures that can be used. So I hope I have cleared the basic foundation and I have also cleared the application level. If any doubts, you can just please ask. Thank you.
If anyone having any doubt or query, they can ask now. You are free to ask in chat also. Okay, ma'am. It seems nobody having any query. So, on behalf of Computer Science Department, I extend my heartful gratitude. Your expertise, clarity, and engaging presentation have truly added immense value to this FDP. We deeply appreciate the time and effort you have dedicated to sharing your knowledge with us. As a gesture of our respect and appreciation, we are honored to present you with the Certificate of Appreciation. Thank you once again for your valuable contribution and for gracing our program with your presence, ma'am. We look forward to more such inspiring in the future, ma'am. Thank you, ma'am.
Thank you, ma'am. Thank you for the opportunity.